All right, let's dive into something that's at the very heart of our digital world. It's a question that honestly sounds a bit philosophical.
I mean, how do you get something incredibly complex out of something incredibly simple? It really does sound like a riddle, right? But believe it or not, this is the exact puzzle that engineers had to solve to build, well, everything around us. And the solution was just surprisingly elegant.
So let's think about the problem. Imagine you're an engineer. You're building a digital circuit. You've got this toolbox, and inside are your essential tools for making decisions, what we call a logic gate. And your main tools are these three guys. You've got the AND gate. Think of it like a super strict bouncer at a club. Everyone has to have an ID or no one gets in. Then there's the OR gate. Way more chill. Only one person needs an ID for the whole group to get through. And finally, the NOT gate, or the inverter. Super simple. It just flips things. A yes becomes a no becomes a yes. These three together are often called AOI logic. That's just AND or inverter.
Okay, so you've got your tools, but here's the catch. If your circuit needs all three of these gates, you have to buy and manage three totally different kinds of parts. And that, well, it gets complicated. It makes manufacturing a headache, it drives up costs. It's just not a very elegant way to build things. So, this led to a really game-changing question. What if you could just toss out most of your tools? What if you only needed one single building block to do the job of all the others? And that, right there, leads us to the heroes of our story today. These aren't just any old gates. Nope, these are special. They're universal. A universal gate is, well, it's exactly what it sounds like. It's a single logic gate that you can use to build all the other ones. And in the world of digital electronics, there are two big superstars in this category. The NAND gate, which stands for not and the NOR gate for not or. The best way to think about this is like a Swiss Army knife or a multi-tool, right? Instead of carrying around a separate screwdriver, a can opener, and a knife, you just carry that one thing that does it all. That's exactly what NAND and NOR gates are for circuit designers. They are the universal multi-tool of the digital world.
Okay, so to really see how this magic works, let's just focus on the NAND gate for a minute. We're going to see how this one little component can basically put on a costume and pretend to be a NOT, an AND, and an OR gate.
First up, the inverter, the NOT gate. How do you make a NAND gate act like one? It is shockingly simple. You just take one NAND gate and literally tie its two inputs together. That's it. Now, whatever signal you send in, it gets flipped on the way out. It's a perfect inverter. So one down, two to go.
Okay, next up, the AND gate. Now, think about the name. NAND is literally not AND. So, to get back to a regular AND gate, what do we have to do? We just have to cancel out that NOT part. And we do that using an inverter. And since we just learned how to make an inverter out of an AND gate, we just stick one on the end. The first NAND does its not AND thing, and the second one, acting as an inverter, flips that result right back. Boom, you've got a perfect AND gate.
All right, last one, the OR gate. And this is the real clever trick. What you do is you take two NAND gates and turn them into inverters for your inputs. So you flip your starting signals first. Then you feed those flipped signals into a third NAND gate. And through a little bit of beautiful logic magic, this whole setup gives you the exact same output as an OR gate. It's amazing. And just like that, we've proven it. The NAND gate can do it all.
So, you might be thinking, okay, that's a cool logic puzzle, but why does it actually matter? Well, this isn't just a neat party trick. This idea of universality has a massive real-world payoff. It's all about making things simpler and more efficient.
So let's imagine a pretty typical circuit, something that uses our original AOI logic. It needs a few NOT gates, a couple of ANDs, and maybe an OR gate to do its job. To build this thing the old way, you'd have to go out and buy three different kinds of chips.
Yup. You'd need one chip type that has your NOT gates on it, a different chip for your AND gates, and a third one for your OR gates. That's three separate components you've got to manage and put on your circuit board. But now that we know about universal gates, we can go back and redesign that entire circuit using only NAND gates, so the number of different chips we need suddenly becomes just one. That's it. The entire thing can be built with just one type of chip. I mean, think about that. That is a huge simplification for anyone designing, manufacturing, or even just stocking parts.
And look, here's the proof in black and white. On the left, you see the original design.
It needs 3 different chips, a 74LS04 for the NOTs, an 08 for the ANDs, and a 32 for the ORs. 3 distinct part numbers. But on the right, the redesigned circuit, it just needs one type of chip, the 74LS00, which is packed with 4 NAND gates. We went from juggling 3 different components down to just one. That is efficiency in action.
Now, it's really important to know that the NAND gate isn't the only hero in this story. It actually has an equally powerful twin. That's right, the NOR gate, or not OR, is also a universal gate. You can do all the same tricks with it. It can be used to construct all the basic logic gates, just like the NAND gate can.
And the patterns are pretty much the same. You tie the inputs of a NOR gate together, you get an inverter. You want to make an OR gate? Just put that inverter after another NOR gate to cancel out the NOT part. And yeah, with a clever arrangement of 3 NOR gates, you can perfectly replicate an AND gate. It's the same beautiful, elegant principle, you're just using a different multi-tool from the toolbox.
Okay, so why have we spent all this time geeking out over these tiny little components? Because this one simple idea is what allows us to build, well, everything.
This incredible idea, this elegant simplicity of building everything from one single repeating part, it's not just a footnote. It is the absolute foundation of modern technology. The computers, the phones, all the digital tech we rely on. They are basically monuments built from trillions and trillions of these tiny, universal building blocks, all working together. And that leaves us with a final thought to chew on. This principle, right? The idea of finding one simple, elegant, universal tool to solve a massively complex problem, it's just so powerful. We've seen how it works in digital circuits, but where else could it apply? What other huge challenges out there could be solved if we just managed to find the right universal tool?